Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question, that is the serialize and deserialize an array tree. So before moving on to the question, if you haven't watched the serialize and deserialize a binary tree, please go and check that video, because in this question, also we are going to use the same concept which we discussed in the previous video, and we can say that in this question it is just an extension of the previous question. Why here we are dealing with the genetic tree, but in the previous question we were dealing with the binary tree. And I believe that if you haven't solved the easy question, then how can you solve the a little bit hard question? So please go and check that video, and if you have watched that video, then let's move on to the understanding part. Okay, so as already told you that in this question we need to serialize or deserialize a genetic tree. So let me at first create a serialize. At first create a genetic tree. Okay, so 10, 20, 30, 40, 50, 60, 70, 80, and this will be 100. Now, okay, I just forgot here 90. So that's base. Okay, so this is a generic tree, and what we need to do it, we need to serialize it. What is the serialize? I have already explained it in the previous video. I'm not going to explain it again and again, so go and check it out. Now we need to serialize it, we know it, and we need to serialize it in such a way that we can that the string we get at the last, we can easily deserialize it and we get the same tree as an output of that string. Okay, and output of that serialized method. So the first thing first is that in the previous question, that is a serialized and deserialized of a binary tree, we use the concept of pre-order, like we were performing the pre-order traversal. Here also I'm going to use the pre-order traversal, just like in the previous question, but there we were doing the pre-order traversal for binary tree. Here we do the pre-order traversal of a generic tree. Okay, so let's have a look how we perform the pre-order. Yeah, one more thing is that just like the previous question, we add some extra delimiter or add some extra checkpoints to just to tell the reader, or just to tell the deserialize method that that here are the breaking points. Okay, here are the important points, and these nodes don't have any of the children. Similarly, here also we will add some extra checkpoints or some extra delimiters to tell the deserialize method that these nodes have completely exhausted and these don't have any of the children. So let's try to understand it. What I'm going to do. So at first, I'm going to do a pre-order traversal. We already know how to perform a pre-order traversal, and we already know how our Euler moves in a pre-order traversal. First, it tries to access the 10, then it moves to the 20. Okay, then it reaches to the 50. Here it reaches to the 50. Now here you can see that 50 don't have any of the children. 50 don't have any of the children. So to tell my delimiter, so to tell my deserialize method, I'm going to add here some delimiter. So I'm adding here 1 minus 1. You can also add the null here or the hash here, anything as a delimiter. Okay, now the after 50 it reaches to the 60. Here I've added the 60. Now the 60 have exhausted, it don't have any of the children, so for it we are going to add the minus 1. Now it again reaches to the 20. Now the moment it reaches to the 20, or we can say the moment we reaches to the post order of the 20, that means we have completely explored that node. Means we can add minus 1 for this 20 also, just because this minus 1 is showing that we have completely explored the 20. There is no more node which the 20 have. So now we reach to this 30. Let me add this 30. After this 30, this 70. Let me add this 70, and after this 70 there is minus 1. Why this minus 1? Just because 70 don't have any of the children. Okay, then this 80, and this 80 Euler reaches to, after this 80 Euler reaches to the 110, and after 110 it reaches to the minus 1. Why? Just because 110 don't have any of the children. Then 120, and after 120 again minus 1. Then again it reaches to the post order of an 80. What the post order explained, I have already told you. Post order means, post order always says that the node have completely explored out. There is no more children which is left to be explored. So we will add minus 1. 120 minus 1, we will add one more minus for this 80. Now there is 90, and we will add -1 just because 90 don't have any of the children, and here we reaches the post order of the 30. So let me add one more -1. Now we reaches to this 40. So the reaching this, after reaching this 40, I've reached this 100, and I will add -1 after this 100. Why -1? Just because my 110 don't have any of the node. Now we are going in a post order of each node. At first, the post order of 100, we have already added the -1 for that. Post order of 40, -1 for that, and post order of 10, that is the -1 for 10. To show or to tell the deserialize method that 10 is completely explored. There is no more no more nodes to be explored out. So what we need to do in this question is that we are going to traverse pre-order traversal, and each time we get any of the node, we will add that node in our string. Okay, and the moment we completely explode out of its children, okay, we get out of its children, we will add -1 as a delimiter. Okay, so that all for the serialize method. This is the final string we get. Okay, now let's try to understand the deserialize method. For that, what I'm going to do, I'm going to create a new tree again. Okay, so then 20, 30, 40, 50, 60, 70, 80, and here it will be 90, 100, and 120, 110, and 120. And this was the same tree whose serial is written here. Serial string is written here. Okay, so now what I'm going to do, I'm going to use this, sorry. But now what I'm going to do is that I'm going to use the serial string, and I'm going to deserialize it and create this same type of generic tree. How we'll do it? Let's try to figure it out. So at first, let me put it somewhere here and put this somewhere here. Okay, the information is actually, yeah, it is fine now. So this is here, this will be here. Now the first thing first is that we can like the previous question. If I discover the if I discuss about the previous question, then we solved the serialize method, deserialize method by a recursive approach. But in this question, we don't use the recursive stack. We are just going to use our own stack, and we will try to solve this question by that stack. How we will solve it by that stack? Let's try to understand it. Okay. So at first, the first thing first is that we have created the serialized string using a pre-order traversal. As we have created it using the pre-order traversal, then we will decode it, or we will deserialize it also using the pre-order traversal. How the pre-order traversal means the moment I keep on iterating over to the string, and the moment I get a non-null value, I behave I keep on adding to the stack. Okay, let me do it. The first thing is that it is a string. Okay, I need to break it into the array of a string. Why I need to break it? Just because it is very easy to randomly access in an array, but it is quite difficult to randomly access in a string. That's why I will break it with a space, or here I will add some space while creating a serialize method. But I will break the moment I start performing deserialize, I will break it on that string. Okay, on that space, actually on that space, and at last what I will get an array of string containing the delimiter and the information both. Okay, so I'm assuming it is an array of string. Now what I'll do, at first my approach will be simple. I'm going to perform a pre-order traversal on a string. Now you might be thinking, how we are going to perform pre-order traversal on a string? Just because we haven't performed it like till now, we haven't performed this. So like how will I do? The moment I'll, okay, so I'll start getting an element from the array, and if that element is a no null value, I keep on creating a new node and keep on putting that node in my own created stack. And if I get, the moment I get a no null value, what I'll do, I just popped an element at the top of a stack, and create a link between the popped element and the current top of stack element. Why I will do it? Okay, let's try to understand it. At first, I'll get this 10, I'll put it into this. At first, I create a stack having the data 10, I'll put it into the stack. Okay, again, I get this 20, I create a new stack, create a new node and put it into the stack, creating this 20. Okay, putting this 20, again get the normal value, that is the 50, create a new stack, create a new node and put it into the stack. Now I get this -1. The moment I get this -1, what I'll do, as I explained, I just remove the top of a stack. I removed it. Okay, I have removed it, and after removing, what I do, I will update the remove node link with the current top of stack. That is, I update this 50 link with this 20. That is nothing but this 20. Why I am updating it? I'm updating it just because this 50 is a children node and its parent. This children parent is nothing but residing at the top of stack. So it in simple terms, I can say that each time when we perform the pre-order traversal using the stack, what we'll do, we will keep on storing the parents, and after the parents will keep on storing its children. Okay, so that means at the top of a stack we don't have nothing but a children, and that children parent is nothing but the second element of a stack. Okay, second top of a stack, we can say that. So this 50's parent is nothing but this 20, that is nothing but a top of stack. So what we'll do, we will update its link with this parent, and the moment we update its link, the flow of a program, or we can say the flow of this creation decentralized method, reaches to this 20. Okay, means the whole control reaches to this 20, that is nothing but a top of stack. So I reach here. Moving forward, I have performed this work of now let's move on to the 60. What I'll do, this is normal value, I'll create its node, I'll add it to the stack. Okay, after creating this node, that is this 60, I get this null value, or I get this delimiter, that is -1. What I'll do, I'll just remove that node from a stack, that is the 60, and I update its link with the top of stack, that is nothing but 20. So I update its link because 60 is the children and 20 is its parent node. Okay, so I'm using the concept that in a pre-order traversal, each like the moment we keep on doing the pre-order traversal, we keep on adding the parents, and on the parents we keep on adding its children. Okay, means at the very deep we are storing the parents, and the children of those parents are stored on them. Okay, so let's continue. After again I get this -1. The moment I get this -1, I pop an element from a stack. This time this 20 get removed out. Okay, and the moment this 20 get removed out, I update its link with the top of stack, that is this 10, and I update its link with this 10. That means 20's parent is nothing but this 10, and here you can see 20 parent is nothing but this 10. And also the flow program or the current control reaches to this 20. Let's move forward. I get this 20, I update, create a node, add to the stack. Similarly, move forward, I get this 70. Okay, I create a node, that is this 70, I push it into the stack. Now again I get this -1. Remove a node from the stack, update it with this parent, that is update this link with this 30, and now my flow of a program or a control reaches to this 30. Again get this 80, create a stack, create a node, add it to the stack. After 80, 110, create a node, add it to the stack. After this 110, I get this -1. This -1 signifies that remove an element from a stack, and the moment you removed an element from a stack, update its link with the top of stack, that is updated link with the 80. Okay, again after updating its link with the 80, I get this 120. So 120 means create a node and add it to the stack. After this 120, I get this -1. That means remove an element from a stack, update its link with the top of a stack, that is this 80. Again -1, remove an element from a stack, update its link with the top of stack, that is this 30. I think till now you get how this program is actually executing. Okay, I'm believing it. You get it. Okay, now this 90, that is the null, create a node, add it to the stack. This -1, remove it from the stack and update its link with the top of stack, that is this 30. Let me remove it. Okay, now the -1 again. The moment I get this -1 again, now my flow reaches to this 10. Why? Just because at the top of stack there is a 30, and which is successfully removed. Okay, which is successfully removed. So this link get updated. Now again I get the 40. Create a node, add it to the stack, and 110. Create a node, add it to the stack. This -1. Remove a node and update a link with the top of stack. That is this 40. -1. Update a node with the top of stack and remove that node from the stack. Okay, and this -1, as this 10 is was a root node, and it don't have any of the children, any of the parent to which it can update its link. So we can even skip that step. Okay, so what is our approach? Our approach is we are going to perform a pre-order traversal, and what we will do in the pre-order traversal, the moment, okay, so one by one we keep on getting an element from the string array of string. Okay, at first step is we will convert the string into the array of string, and the moment we keep on getting no null value, we keep on creating a new nodes and we keep on adding it to the stack. Okay, and the moment we get the null value, okay, just remove a node from the stack and update its link with the current top of stack, enough faith that the removed element parent is nothing but a current top of stack. Okay, so that's all for the explanation. If you don't get it, there may be a possibility that there is some confusion you faced while the understanding. So it's my request you go and try to solve this question by yourself. Okay, so that's all for the explanation part. Now we are going to move on to the pep coding portal and we will write the code. Okay, so this is the pep coding portal. Let's try to code it here. Yeah, in the serialize method. Okay, so at first we will create a string builder. Okay, string builder to store a serialized string. Let's be a new string builder and serialize root sb. Okay, and at last I just need to return this sb dot to string, just because this we need to convert the string builder into a string. Okay, otherwise it will throw an error. Now let's complete the function of serialize. Let's create this function, public static void serialize node root and string builder sb. Now if this is not a binary tree. Okay, so at first sb dot append root dot val plus this space. Now for node child node dot children, root dot children actually, just because here we have declared the name as root dot children and serialize serialize child sb. And at last what we need to do, sb dot append the null. Here I'm adding null as a delimiter. Okay, adding null as a delimiter. So that's all for the code of a serialize. Let's write the code of deserialize. Okay, so what we need to write in the deserialize method, what was our concept? At first we need to convert this string, okay, into a string array equals to str.split. Similarly return deserialize array. Let me again create it. Okay, oh sorry, Control C. Let me again create this method. So it will be public node, public static node actually, public static node deserialize and string array. Now at first what we will do, we will create our stack, because approach we have discussed on in that approach we were using the stack node st equals to new stack. Now for int I equals to 0, I is less than array dot length -1 and I plus plus. Now we are iterating over the array. Which array? The array of strings. Now at first let me get that value as equals to array at I, array at that position I. Let me get that value. Now after getting that value, I need to check that whether that value is equals to the null, whether that value is a delimiter. Okay, if it is a delimiter, what I need to do, I just need to pop that value from the stack. Node st dot pop a value from the stack, and I just need to update that string, that at st.peak.children, st.peak.children.add node. Otherwise what I need to do, else I will create a node with a value of integer.parseInt, integer.parseInt s, parseInt s here, and integer.parseInt s, and need to push that value back into the, that is stack.push here, st.push stack.push node. Okay, now at last when we completed this loop, we need to return something. If stack.size is not equals to 0, if such a case arises, what we need to return, we just need to pop something from the stack, otherwise we will return null. Okay, stack.size is not equals to 0, then we pop something from the stack, that is the root node. Okay, if the stack size is not 0, then what remains in the stack, it will be nothing but a stack top, otherwise we will return null. So that all for this code. Now what we are going to do, we are going to run it and we will check whether it is running for all the test cases or not. So let me run it. It is taking so much time. Okay, yeah, it is accepted. Let's try to submit it for all the test cases. And that's all for this video. I hope you like the content. If you liked it, please hit the like button, share it with your friends, and yeah, we get the correct output. So that's all for this video. Let's meet in the next video.